Hello everybody, Mr. Hinnon here, another Henstitute Help video. Okay, so this one's a little bit different than our polar bear, but it has some of the same basic idea. So it says, what's the radius of a hydrogen-filled balloon that would carry a load of 5,750 newtons, in addition to the weight of the hydrogen, when the density of air is 1.29 kilograms per cubic meter and the density of hydrogen is 0.0921. Okay, so we know hydrogen floats in air, or a hydrogen balloon would float in air, just like a helium balloon would, because the density of hydrogen is less than the density of air. That's the reason why. If you could make your density less than 1.29 kilograms per cubic meter, you would also float in air. However, that's nearly impossible because we're mostly made out of water. We float in water. We are somewhere around 1,000, maybe a little bit less because we float, so somewhere in the high 900s. Gonna be really hard to get down to 1.29. So here is the idea. I'm going to draw out this picture just to kind of make it easy. So we've got a balloon, sealed off, and I'm going to start drawing out the different parts. Okay, first off, easy one is there's a buoyant force on this thing. The entire balloon is in the air, so this is going to be the density of air, because that's the displaced fluid. The fluid that's being displaced by the balloon is air. It's pushing the air out of the way so that it can float in the air. But it's going to be the volume of the balloon times gravity. So there's the buoyant force. What else do we have? Well, they mentioned that there is some kind of load on this thing. I'll just say it's some object. So it's going to have a downward force that's just going to be equal to the weight of the load. We don't have to calculate that. That is this number. So that's just the 5,750 newtons. Don't break it down into mg's or rho vg's or anything like that. The other thing is the balloon also has weight itself. And what we're doing is we're just going to say it's the weight of the hydrogen. So for this one, just to make it easier, I'm going to say another downward force is the weight of the hydrogen. So it's going to be the force of gravity of the hydrogen. That could be equal to the mass of the hydrogen times gravity, but I'm going to write it this way. I'm going to say it's the density of the hydrogen, Hy, times the volume of the balloon, so the entire balloon, times gravity. Okay, so that's my setup. That's the first thing. Like I said with number 8 and number 7, you have to draw these free body diagrams. Now I can set it up that the buoyant force is going to equal the weight of the hydrogen plus the weight of the load. Okay, now what we're after is actually the radius of the balloon. You're like, huh? How do I get to that? Well, that's going to be hidden in the volume of the balloon. Okay, so here's going to be my suggestion. Is I'm actually going to solve for the volume of the balloon, and then I'll plug it into this equation. So the balloon, we're going to assume is a sphere. So its volume is 4/3 pi r cubed. Because when you blow up a balloon, it pretty much is spherical in shape. Now, if I really wanted to be picky, I should have written that down. But if they ask for the radius of it, you kind of have to make it some kind of spherical shape. So what I'm going to do is I'm actually going to solve for this and use it to figure out what the radius is. Okay, so that's how I'm going to solve this problem. So over here, I'm going to have the density of the air, the volume of the balloon, let's write VB, and then times gravity, and this should equal the density, the density of hydrogen times the volume of the balloon times gravity, and then finally we have that load. So I want that volume of the balloon. So what I'm going to do is I'm going to subtract it over to the other side. So I'm going to kind of change this equation. I'm just going to use the power of my little board here. I'm going to erase this. I'm going to erase this. I'm going to turn this into a subtraction. Oops. Get my pen. And turn this into a subtraction because I subtracted it over and now it equals this. Then what I can do is I can factor out that volume of the balloon. So I have the volume of the balloon times the density of air times gravity minus the density of hydrogen times gravity, and that should equal this 5750. Then what I'm going to do is once I calculate this, I'll divide it over to find the volume of the balloon. So the idea is I can find the volume of the balloon, then put that in there, and bam, I've got the radius of this balloon. So lots of little steps. The key thing in this is even though we're using Archimedes' principle, which is this buoyant force equation, realize that you're still drawing free body diagrams. I hope that helps.